6 general revision videos for Foundation Tier Maths GCSE based on the revision mats available from pixiemaths.co.uk. So probability, this is probably one of the most straightforward areas if you get probability. So I'm just going to start off with these basic ideas of probability on the left hand side. Probability, I roll a normal 6-sided dice. What is the probability that I get a 6? So there's only one side that has a 6 on it out of the 6 available sides of a cube. An even number, we're talking about 2, 4 or 6, so that is 3 out of the 6, which is also 1/2. A number less than 2, not including 2, so I'm talking about an outcome of 1 only. There is no 0 on a dice, so I've got 1, and that is the only outcome that would count as less than 2. So I've got 1 out of 6 for that one as well. Question 2, the spinner shown is spun, should say is spun. What is the probability that the spinner lands on red? We can see that's only 1 out of the 4. Red or yellow, that is 2 out of the 4 options, could also be written as 1/2. Not blue is any of the other 3, so that is 3 options out of 4. Question 3, I put the letters from the word exercise on cards, place them face down and then mix them up. I pick one card at random. What is the probability that the card is an X? So all of this preamble is really just leading to a quite predictable question. All of this is just a description to make sure that the whole process is completely random. So the probability that the card is an X, there is only one X out of a total of 1, 2, 3, 4, 5, 6, 7, 8 letter cards. Probability that it's a vowel, we've either got this E, or the other E, or the I, or the E. That is 1, 2, 3, 4 out of the total of 8. Also 1/2. And just to confirm, a vowel in that context, A, E, I, O, or U. Any of those 5 vowels would have counted, but obviously we've only got 2 in that word. Probability that it's not an E, so we've got how many letters are not E? 1, 2, 3, 4, 5 out of the 8. Question 4, the probability that I will win a 100-meter race is 3 out of 10. What is the probability that I don't win the race? This is the idea of mutually exclusive events. Winning and not winning are mutually exclusive. So the outcomes of mutually exclusive events always add to 1. In general, we're just thinking about 1 minus that option. 1 minus 3/10 is 7/10. Same idea in question 5. The probability that it rains tomorrow is 0.14. What is the probability that it doesn't rain tomorrow? 1 minus 0.14, which is 0.86. Onto the frequency trees box. So frequency trees are like probability trees, but instead of writing probabilities, we are just writing frequencies within them. So 200 adults go on an international flight. Each travel with a suitcase or a rucksack. 70 are men, 50 men and 115 women have suitcases. Fill in the frequency tree diagram. So I start here with my 200 adults. 70 of them are men, and logically, therefore, of these 200, 130 have to go in that box. We can see from the branches here, it's a binary decision, either or, so 70 or 130. 50 men have suitcases, and 115 women have suitcases. That means that those with rucksacks are the remaining 70 minus 50, which is 20, and 130 minus 115, leaving 15 women with rucksacks. We should find with a frequency tree that our answers always add up to the total. So in each line, 130 plus 70 equals 200, and here 50 plus 20 plus 115 plus 15 also adds to 200. Question 2, what is the probability that a passenger chosen at random is a man with a rucksack? So we're talking about men only with rucksack, that is 20 out of the total of 200, which could also be written as 1 in 10 when you simplify it. What is the probability that a passenger chosen at random is a woman with a suitcase? So it's got to be from the women branch and suitcase. That is 115 out of 200. We can divide top and bottom by 5 here. That is 23 over 40. This answer is fine though. 115 over 200 is perfectly good for that question. Okay, on to sample space diagrams. Sample space diagrams are these diagrams where you list all of the outcomes. So we've got 2 fair dice thrown together and their scores are added together. Always check what happens with the scores. Complete the sample space diagram showing all of the possible outcomes. So I'm adding them together. 1 plus 1, 2. 1 plus 2, 3. This is going to carry on like that. 2 plus 1 is 3. 2 plus 2 is 4. That's going to keep on going like this. 3 plus 1. And because we've got the same numbers here and here, we end up with this diamond-shaped outcome in terms of all of these diagonals. Sorry, that should have been a 6, not a 7. Wrong. So we can see that all of these diagonals are the same in this case. Always worth checking that to make sure you haven't made a simple mistake somewhere. How many outcomes are there altogether? Well, we've got 6 in this direction and 6 in that direction. 6 times 6 is 36 outcomes in the grid that I've written in there. What is the most likely score? Well, we can see that the longest diagonal of these same scores is with 7s. There are 6 7s there, and anything else is fewer of the number. So most likely score is a 7. What are the least likely scores? 2 least likely scores. They're in this corner. There's only 1 2 and there's only 1 12. So 2 and 12 are the least likely scores. So the probability of scoring 10 or more, that includes the 10 or more than 10. So we've got 1, 2, 3, 4, 5, 6 outcomes there out of the 36, which simplifies to 1 in 6, dividing top and bottom by 6 there. What is the probability of scoring less than 5? That doesn't include 5, it's just less than 5. We've got 1, 2, 3, 4, 5, 6 options there that are less than 5. So again, 6 out of 36, which cancels to 1/6. Next box is systematic listing. So 3 friends, Andrew, Billy and Chris, are sitting in the same row at a concert. Show the different seating arrangements that are possible. So being systematic about it, if Andrew sits at the front, he could have Billy next to him or Chris, or Andrew could be sitting next to Chris, then Billy. Then if I put Billy at the front, he could be next to Andrew and then Chris, or Billy could be next to Chris and then Andrew. Or I have Chris at the front, next to Andrew and then Billy, Chris next to Billy, then Andrew. And at this point I have done all of the possible options because only one of the 3 can sit at the front each time, and for each of those sitting at the front, or first to the left, I've done all of the possible options. If I've ordered them systematically like that, I can make sure I haven't missed any and that everything is matched up. So it's better to do it systematically rather than just guessing at different options. Same is true for this one. Question 2, a restaurant menu allows a choice of 1 of each starter, main course and sweet. The choices are listed here. So I can either have, and I'm going to be systematic about it again, I'm going to start with melon and do everything involving melon first. So melon pasta gatto, melon pasta ice cream. Then melon fish gatto, melon fish ice cream. Melon chicken gatto, melon chicken ice cream. And now I've been through all of these 3 in the middle position and for each of them in the middle position, I've used each of those at the end position. So now I realise I've done everything to do with melon at the front. Now I'll try everything with soup at the front. So same things: soup pasta gatto, soup pasta ice cream, soup fish gatto, soup fish ice cream, soup chicken gatto, soup chicken ice cream. And then I've got the same number of each of those, and so I can check systematically I've got everything that I need there. Relative frequency. The probability that a biased dice will land on a 5 is 0.3. Megan is going to roll the dice 400 times. Work out an estimate for the number of times the dice will land on a 5. So if the probability of it landing on a 5 is 0.3 for each roll, and I'm doing that roll 400 times, it's just a case of 0.3 times 400, which is 120 times. Question 2. Jack sows 300 wildflower seeds. The probability of a seed flowering is 0.7. Work out an estimate for the number of these seeds that will flower. So again, probability for each seed is 0.7. I have 300 of these seeds, or Jack does. So 300 times 0.7 is 210. You can always just check this, you'll answer the right kind of size. It's more than half of 300, so just like 0.7 is more than 1/2. So that all works there, and I think that's it. Yep, that's the end of the probability worksheet.